So in the past videos we've been talking about pi and figuring out how we get 3.14 for pi. And for this circle below, using the diameter, which is 1 foot, we noted that each 1 foot section along the circle will represent 1 unit. So we should all be in agreement here that this 1 foot section along the circle represents the first unit, or 1 unit. The second 1 foot section along the circle represents 2 units. This third section along the circle represents 3 units. And finally, this last section, well, it's not 1 foot in length, it's a fraction of a foot. It's 0.14 feet in length. So this represents 0.14 units. Now when you add all of these units up, it's roughly 3.14 units. But in one of the first videos I noted 3.14 is an approximation for pi. It's not the only number that people use for pi. Now let's grab another color real quick and change pens for a second, and we're just going to take a look over here at different values for pi. Now remember, pi is a ratio. It can be written as the circumference to the diameter. Let's rewrite that real quick. So the value for the circumference over the value for the diameter. Now if you were to actually plug values in for the circumference and diameter, either into a calculator or run it by hand, you'd get a very long number. That's because pi is a number that goes on forever. It never stops. In fact, it's an irrational number, so let's write that down real quick. Irrational meaning we have a number that has a decimal, but that decimal's value, it's non-terminating. So this 0.14 goes on forever after that. Also, it's non-repeating, so the values after the decimal don't repeat. So let's write that down real quick. It's non-terminating. So non-terminating and non-repeating. And non-repeating just means that after the decimal, you won't see the same values follow a certain pattern after that decimal. You won't see the same values reappearing. So what are some of the other values you can use to represent pi? Well, sometimes in math books or in math problems, what you'll see is, well, they'll give you the symbol for pi, and then after that, they'll give you some values to use for pi. They might say that pi is approximately 3, so use 3 for pi. Now remember, pi is an irrational number that never stops, so the longer the number you use to represent pi, the more accurate that value will be for pi. But if you were to cut off all the numbers after the decimal and just use 3 to represent pi, it's okay to use 3, it's just not as accurate as a number as a longer number would be. So we're going to say 3 is a rough estimate for pi. Let's just write that down, rough estimate. Sometimes, rather than seeing the value 3 for pi, a problem's going to state that pi is roughly 22 over 7. So let's write that down, 22 over 7. And the problem might even ask you to round to the nearest hundredth. So let's write that down, round to the nearest hundredth. So when you see a ratio written as 22 over 7 to represent pi, think about it as 22 being the circumference, 7 being the diameter. Now if you were to calculate this out, the value you would get for 22 over 7 would be 3.142. And you would use this last digit to round to the nearest hundredth, which the hundredth position is where the 4 is. Since 2 is a smaller value than 5, then we're just going to round down or keep 4 the same. So we could say that 22 over 7 is roughly 3.14. Now 3.14 might be an estimate or an approximation for pi, but 3.14 is more accurate than 3 because the number has more digits in it. In fact, it has 1, 2, 3 significant figures or significant digits. Let's just write that down real quick. 3 significant, I'm just going to write sig digits here, significant digits. Okay, so what I want to do from here is just try to get all this information moved over. So give me a second just to cut all of this information out. Cool. So we're going to move this information over. Then I also want to go ahead and just cut this information and slide it down just a little bit. Okay, so sometimes you might use 3 to represent pi. It's a rough estimate. Other times you might be asked to use 22/7. We're going to treat that as the circumference over the diameter, and you'll have to do some calculations to find out that pi is roughly 3.14. So you have 3 significant digits for 3.14. It's an estimate for pi, but it's not as rough an estimate as 3. But still, other times you might be asked to use a more accurate number. So a more accurate number to represent pi will have to be longer than 3 significant digits. It will have to be longer than 3.14. So sometimes a problem might tell you that pi is roughly 3.14159. Cool, so we can use this last digit to round to the nearest 10,000th place value. So 9, it's larger than 5. So in this situation, we'll round up. So pi is roughly 3.1416. So in this case, pi is represented by 1, 2, 3, 4, and 5 significant digits or figures. Let's write that down real quick. 5 significant digits. And let's fix that I real quick. So a number with 5 significant digits is more accurate than a number with 3 significant digits, which is much more accurate than this value 3, which is our rough estimate. Now all 3 of these numbers are estimates of pi. They're approximations. However, 3 is just a rough estimate for pi. Since 3.14 has 3 significant digits and it's a longer number than 3, 3.14 is a more accurate value compared to 3 to represent pi, and 3.1416 has 5 significant digits. This is a longer number than 3.14 and 3. Therefore, 3.1416 is a more accurate number than either of these two numbers to represent pi. Regardless of the value you use to represent pi, just remember, if you need a value of higher accuracy, use a more accurate number. Finally, if you're dealing with fractions to represent pi, a fraction with a larger number in the denominator will give you a more accurate value to represent pi. Cool stuff, guys. I'll see you in another problem.